Hello and welcome to the third unit of the IPOP course. And in this unit, I'm going to cover virtual networks within the context of a single cloud provider. So the goal is to provide an overview of how virtual networks work within the context of a single provider so we can better understand the challenges that arise when you try to connect virtual networks across multiple providers, which is the topic of the next unit. So to cover this, I'm going to use some examples as technologies and techniques that are available currently, and based on these examples highlight the features and limitations of these approaches. And the three examples that I'm going to cover, one is a commercial service provided by Amazon Web Services, which is the Virtual Private Cluster, or VPC, which is essentially a virtual private network that can work within Amazon infrastructure or also extend to the enterprise for use case scenarios that we discussed earlier, like cloud bursting. Then I'll talk about OpenFlow, which is a specification that is getting increasing adoption, and that provides essentially a programmable interface to networking infrastructure, and thus provides a standard and a basis for creating different kinds of virtualization implementations on networking infrastructure. And finally, I'll talk a little bit about OpenStack Quantum, which is an extension to the OpenStack infrastructure as a service cloud software to enable virtual networking within a private cloud. So beginning with Amazon VPC, this is a service that's available for customers of the Amazon cloud, and it's available through a service API and through a web console. So if you're a user of Amazon, you'd be able to request the service if you're interested. It's a layer 3 virtual network within the Amazon EC2 infrastructure, and it can also extend back to an enterprise local area network through hardware virtual private networking connections. So the typical use cases that this service targets multi-tier applications where you may have a web server, for example, that needs a public address on the internet, but then you can also have private services like a database and an application service that do not need to be exposed to the public internet. And in fact, it may be a good idea not to expose them to minimize the possibility of compromises. Another use case would be extending data center on demand, like I covered in the first unit. This is the cloud bursting use case scenario for virtual networks. So from the documentation, VPC lets you provide keywords here, private isolated resources, and bind virtual machines on Amazon cloud to these virtual networks. And the user has control over the virtual network environment. Like we discussed in the first unit, it's important to have customization and isolation. So you can select your own IP address range, you can create subnets, and you can also connect again back to the enterprise network with a hardware virtual private network if you have equipment that supports the VPN technology that's used by Amazon Web Services. So here's how one could see Amazon VPC being deployed. To the right here we have an EC2 infrastructure with a number of different users or tenants, and these have different colors. So the user in red, for example, can have a virtual private cluster within the Amazon infrastructure. So isolation from other users in the system. The red user can select their own addresses, their own address space, and connect resources to this to their own virtual private cluster. And they can, for example, have a virtual machine, the one to the left, which has two interfaces, one public on the internet and another that's private and only visible within the virtual private cluster within Amazon. So for example, the public server could be a web server, and the private machines could be a database and application server. The blue user could extend the local area network enterprise cluster to connect to the Amazon virtual private cluster. In fact, they could have just private nodes on the Amazon infrastructure and connect back to the local area network using virtual private network router, following the example that we covered in the previous unit. So again, the important thing here is that the user is able to manage the address space. So if they have a local area network with a particular private address space range, like 10.10 private address spaces, they can assign addresses within that range on virtual machines that they establish, they deploy on Amazon infrastructure. So again, there's a web interface, like other services on Amazon. You can configure them, for example, set up the subnet you want to use, what virtual machines you bind to this virtual private cluster, and also have service APIs through the web service interface. Usual. One issue with this approach is that it's a custom approach for Amazon services, so it's not intended to interoperate with other cloud providers. The second example that I wanted to talk about is OpenFlow, and this is a very important system or standard that's being built towards an open platform supporting software-defined networks, broadly virtual networks that can be programmed in software. So this is an interface that's been standardized by the Open Networking Foundation. It has several members from industry behind this, and it's already available in products and available also in software implementations of virtual machine monitors that support this standard. So OpenFlow, what is very interesting about it as a platform for virtualization is that it provides a basis for what we discussed in Unit 2, which is implementing virtualization techniques on top of network abstractions. So basically on OpenFlow, every packet that comes through an OpenFlow port is processed through a data flow pipeline. And there's also the ability to, if there's no matching function, so to speak, inside an OpenFlow device to handle that process, that flow, that packet, it can be sent to a controller that implements a logic needed to handle that packet.